Good day, sir and everyone. My name is Ong Le Foo, and today I want to talk about converting the audio into an image. First, let's talk about this assignment. This assignment requires us to convert an audio data into spatial data representation using basic knowledge of image processing and understanding of audio and speech processing. I will need to produce a better or enhanced solution that will use attributes to show the audio data in a better and understandable spatial data representation. The understanding the attribute and pattern of the audio are needed in order to produce an image from each audio. The given solution provided to us is that it uses a very simple direct mapping from point to point with no attribute at all. The output is in grayscale. As you can see from the image, that the producing image is like this. You just go up and down and it's from point to point. Although it is actually can show the feature of the sound, but it is not the best because it doesn't use any attribute at all. So we need to improve it and give a better solution to it. So for my proposed solution, I decided to separate the audio into frames. And each frame will have the size of 256. After separating the audio into frames, I calculate the energy and use the energy as variable to convert it into a spatial data representation. So here, as you can see, the data has, this is the idea, separated by frame, and then on each frame, the energy will go through on each row. Until finish the row, then it will go to the next column. Using energy as an attribute could easily let the viewer understand the audio. By looking at the intensity of the color, viewer can differentiate which part has a higher value of energy and which part has lower. This is the flowchart of the proposed algorithm. The first thing that we need to do is we need to load and read the audio file. And then after that, we calculate and separate the audio file into frames by the size of 256. After separating the file into 256, we will calculate the energy on each frame, and then find the minimum and maximum energy for the normalization of the value that will be used for later on. And then, based on the energy, we determine the color and color intensity using the energy value. After that, we normalize the value into between 0 to 1. Then we map the value into an array. After that, we reshape the value into a two-dimensional matrix so that it can be drawn into an image. And then we divide the matrix value to show a better contrast. And then lastly, we will display the spatial data representation. So this is the full script. The detail of the script will be explained later on. I will show it slide by slide. So these are the procedure. First thing, this is loading the audio. So first, we will use a plot. This one is to actually show how the image look like, and then we read using audio read, and then we after that plot it, and then we call the sample map 18. This is actually the function that will be used to map the audio into an image. So in this one, this is the function of the sample map. So first thing, I declared the win as a variable for the frame. So each frame is actually the size of 256. And then right here, f equal to floor square root round length a divided by win. This one is actually the square root number of the frame produced from the audio. Square root is so that after that we can be used easily to declare the dimension of the size of the image. And then this loop right here will calculate the energy on each frame and store it into an array. And then the minimum and maximum value, this one is to find the value of the energy, minimum and maximum. And then this half is actually for determining the color later on. After we found the energy of each frame, it is time to map the audio. I use a simple RGB where the higher value of the energy will be red. And then gradually it will turn into yellow or green. And then lastly it will be blue, which means the higher energy will be red and the lowest will be blue. And then using different color saturation and color intensity to represent the spatial data can help an easier understanding. And the color in MATLAB uses three values, which is R, G, and B, to represent the color. So a metric that has a color will need three metrics to represent it. And so for example right here, B, will actually have three different metrics to represent the color. So one is actually the red color, two is actually the green, and three is actually the blue color. And the color will change based on the energy value of each frame. So I put a loop here where actually it goes on each frame, and then it will take the value of the energy. If it's more than half, the value will change based on red and green. The green will be inversely proportional to the red color, and if it's less than half, the color will change from between green and blue, and blue is actually inversely proportional to the green. And here I put a bit of red so that when it changes from the more than half to less than half, the color won't differ too much. And this part is also the normalization part, where I normalize the value into between 0 to 1. So this is the basic formula. Normalize x is actually x minus the minimum of x over maximum minus minimum. So the reason I want to divide it, normalize it into 0 to 1 is because that the way that the image are drawn use the pixel value count from 0 to 1. After that, I reshaped the matrix into two-dimensional. It was one-dimensional before. It was only one column, and now the mapping array produces one-dimensional array with value of 1 column. I reshape it to produce a two-dimensional matrix so that it can draw the image. After that, I divided the matrix by 0.5 to show a better contrast. And this is actually the output. So I used 3 different audio and to test the output. The spatial data representation represents the energy frame by frame of the audio. So as you can see right here, for example, this here, it is actually this part right here. So it's where the energy is high so that it displays a much redder color, and then gradually right here it is all blue. And then this is the same for here. There are many parts that has a high energy and low energy. So it has many parts that has high energy, and there's also many parts that has low energy. And this part is I think is quite in the middle. The energy is in the middle, so it's not as red as the other. So the third one also has the same. This part has a bigger, higher energy. So this part is much redder, and then compared to the behind, it is much blue. So the output shows the frame that have higher energy are red and the lower with darker blue. Each audio has their own unique pattern when turning into the spatial data representation. And lastly, in conclusion, the proposed method really works and shows the audio using attributes like energy into a spatial data representation. From what I observed, I found that it is very interesting using energy of the audio of each frame, and converting it into an image can let the viewer understand the feature of the audio. From this assignment, I had understood more about image processing and speech processing and the process of converting the audio into an image. There's also still many other possible ways to represent the data, such as using other attributes. And then I conclude my presentation. Thank you.